So in this video, I want to tackle our next powerful tool in our regular expression toolbox to help answer a question were all really interested in when we first talked about grep. So one question that came up quite frequently was, how do I search in grep for all lines that contain an A or? The way this works in grep is we use the or symbol to represent an or in our pattern. We're going to use grep-e for regular expressions. And then I'm going to search for A, and then the regular expression syntax for or is that vertical bar, and then E. And then I'm just going to search in candy.txt. So this pattern is read A or E. Now you can search for more complex things. So for example, what if I wanted to search for all Twix or tart? Then it will show me that. But that or is kind of that separator. You do have to be a little bit careful. For example, spacing matters. So for example, if you try to make it look all nice and pretty by searching for like putting spaces between the or, this will only find that sweet tarts because it's searching for Twix space or space tart. So you have to be a little bit careful. Everything matters in the regular expression. It's not like you can't just add extra spaces just fun. Now, one thing usually when you are kind of using these or patterns, you can search for really whatever you want. So for example, I might try search for all things that contain ET or AT, or AT, candies.txt. So that's searching for all things that either contain ET or AT. Now, one thing is sometimes if you're searching for things where there's a lot of repetition, like for example, instead of T, you're searching for a whole word, you can always combine these using parentheses. So what you could do instead of writing ET or AT, you can kind of reduce that redundancy by saying search for all E's or A's followed by a T. If you use parentheses, that's a special regular expression syntax for grouping things together. So the way you'd read this is, okay, first we're going to search for E's or A's, then followed by a T. This is an equivalent regular expression to what we had before, but one thing that's nice is now we can add on extra cases. Like for example, if you want to add more ors, you can search for E or A or R followed by a T, instead of having to copy kind of all of that trailing code. So these strategies are the same in some sense, but usually this one of kind of extracting out the common things by putting them outside parentheses is a really nice way of reducing redundancy, better capturing what you're actually searching for. Now, what if you're in, I'm going to go ahead and edit extra S's. Now, what if you wanted to find something that was something like all E's, any T with an E in front of it? You could search for that ET like before. But what if you wanted to match any number of E's beforehand? So for example, you wanted to match ET or multiple E's. Like maybe if I go in and make this wheat parts, you'd want to make sure it matches kind of that whole sequence of E's. Well, there's a special regular expression syntax for star. Star means 0 or more. So the way we read this is 0 or more E's followed by a T. So we get this here. Now notice kit and cats are in this output because they have 0 or more E's followed by a T, right? 0 E's is valid in 0 or more. But do notice that in this setup, this sweet tarts only matched once for that long string of E. Regular expressions in grep are greedy, is the term that we use for them, to match the longest string possible. So it's kind of going to try to grab as many E's followed by a T as possible. So there'd only be one match there. Now, if you don't want to include kits and cats and etc., just because they have 0 E's, instead of using the star, you use the plus. So star means 0 or more, plus means 1 or more. And so you could get that there. There's always a fun way that you can always recreate the plus without it. You could say E star. So one E followed by 0 or more E's is equivalent to 1 or more E's, the same thing. So that's a kind of fun way of going about this. One other very useful modifier is instead of asking for 0 or more, you might ask for 0 or 1. And the way we do that is with the question mark. So question mark in this context means 0 or 1 E's followed by T. And this gets us something similar to that E star, but it doesn't allow for multiple E's in a row. It's only about 0 or 1. Now, one of the awesome things about regular expressions in this context, using these modifiers, star, plus, and question mark, is they compose with everything that we had before. So you could say, what if I wanted E or A, optional, followed by T? You could do something like that, or you can search for E's or A's plus and follow that. So this is all sequences of E's and A's of one or more of those plus a T. Do note that this would end up matching if you added some A's in there. That would match that whole thing, because this pattern is saying one or more E or A. And so it doesn't have to be all of the same sequence, which is pretty nice. So that's kind of a lot of those things, like those basic modifiers that you're going to use all the time. So these, maybe basic's not the word, but the kind of core modifiers. One kind of weird example I kind of just want to show you here, just because it sometimes comes up and it looks a little weird when you see it. If you search for E star, take a second and think about what should this show up in this file? What will show up in our results? Where will the matches? So you might be thinking, okay, it's going to highlight 0 or more E's. And so something like in the sweet tarts and the chocolate, there should be E's. And you're right, it will highlight all of those E's. But notice it prints every line of the file. Why does it print every line of the file? Because every line matches. Every line in this file contains 0 or more E's. You just don't see it being highlighted because it's highlighting the empty string between all the characters, and you can't see that. So that's just one thing to notice is sometimes this star behavior can get a little weird. And so a lot of times you usually end up using plus a lot, but star is something that's valid. If all of that was a little bit confusing, do remember we have this reference glossary of things to look up for. And you can always compose them with everything we just used, with parentheses and all that stuff. And just like with last time, because all of these characters are special characters in regular expressions, if you ever want a literal question mark, you have to escape it. So now what I want you to try is I want you to try a practice problem. So I want you, this one's going to be a little bit more complex. So using our tool of trying to break down the problem into smaller parts, suppose we have this kitcats.txt. Ignore I say candies.txt. There's another file called kitcats, which just has a bunch of different KitKat words in it. We want to print out all lines containing KitKats with the following criteria. So we want to start with an upper or lowercase k. It may or may not contain a space after that first T. The second K may be upper or lowercase, and it optionally ends with an S. So all of these blue ones up here should match, while this red one should not. So take a second, try this out. Write the full grep command to do this. Okay, so hopefully you had some time to work on that. Let's go ahead and try this out on together. So I'm going to open up kitcats.txt that has all of files in it. And like usual, I'm going to always try to tackle this in parts. So start with maybe finding all the lines. Oh, whoops, did I? And I didn't. Let's start by trying to find all of the lines that start with an uppercase or lowercase k. Now, you might think, oh, I know we could use that -i flag to do case insensitive. Whoops, I forgot to put kitcats.txt, which should be fine. But we might already start to see a problem with this approach because I is going to do case insensitive for the whole string. And we said here that we only want the K's to be optional upper or lowercase. Everything else should be lowercase. So instead of using that -i flag, because we don't want to search the whole string case sensitively, we might have to explicitly spell out lowercase or uppercase k. And the way we could do that is with this or. So here, I'm going to put lowercase and uppercase k. Right now, we don't necessarily need these parentheses. This is equivalent. but we're going to include them in there because I know I'm going to add some more stuff on later. So this finds me everything that's the same. Great. So what else was in this problem? We found words that start with an uppercase or lowercase k. Now we need to match the it part, and it may or may not contain a space. Let's just double check that we can get this working. So if we type it, then we get all those hits. But if I put a space here, now it's stopping matching the ones without a space. So I need some way of saying optionally include a space. Now, how do I do that optionality? Well, that was what that question mark is for. We don't want question mark, or sorry, space plus. We don't want one or more spaces. We want an optional space. And it might be tempting to use the star because it's 0 or more. In the problem statement, I said may or may not contain a space. So that indicates 0 or 1. But if it said may or may not contain spaces, then that star would be appropriate. But here we want 0 or 1. So I'm going to search this. And now we can start searching for that cat. So I'm going to do lowercase or uppercase k again, because I need that same pattern for that lower uppercase k for that third bullet point. And I'm going to do cats. But here again, we didn't quite hit all of these because we also wanted that S to be optional. So how do we make something optional again? Well, that's what that question mark is. So notice I've tackled this in parts. I didn't tackle all of it once. I ran the command multiple times to solve it bit by bit. This is a really important testing strategy that you're going to want to use when it comes to trying to develop these, ask you these problems that contain multiple parts. Try to solve it one piece at a time. In our next video, we're going to introduce one last regular expression concept, which is called a character set, which we can do things like matching any letter or matching any number.